let's try to compare the strength of electrostatic and gravitational forces. So we will do this problem. Here we have to work out the gravitational and electrostatic forces of an electron and a proton in hydrogen atom. So we will try to work out the electrostatic force to gravitational force ratio. So Fe upon Fg is equals to Ke square upon R square upon Gme upon R square. R square and R square get cancelled off. So you will get Fe upon Fg is equal to Ke square upon Me Gmemp. K is equals to 9 times 10 to the power 9. Universal gravitational force G is equal to 6.67 times 10 to the power minus 11. MP is equals to 1.67 times 10 to the power minus 27 kilograms. And ME is equal to 9.1 times 10 to the power minus 31 kilogram. Let us put these values into the equation and you will get Fe upon Fg is equal to 9 times 10 to the power 9 times 1.6 times 10 to the power minus 19 times 1.6 times 10 to the power minus 19 upon 6.67 times 10 to the power minus 11 times 1.67 times 10 to the power minus 27 times 9.1 times 10 to the power minus 31. When you work this out, you will get the ratio is equal to 2.27 times 10 to the power 39. So Fe upon Fg in this case equals to 2.27 times 10 to the power 10 to the power 39. So you can see that how strong electrostatic force compared to the gravitational force. It's about 10 to the power 39 times stronger. Electrostatic force is about 10 to the power 39 times stronger than gravitational force. Here is a question. 2 point charges plus capital Q and plus capital 2Q are placed r meter apart in air. A third charge small q is placed on the line joining the two charges in between such that the system is in equilibrium. Find the position and the value of small q in terms of capital Q and R. So this is the question. So here we have two charges, Q and 2Q, separated by a distance r in area. So we have Q and 2Q. And a third charge is placed somewhere in between on the line joining, which is small q. This makes the system in equilibrium. This brings the system to equilibrium. It means that all the forces are cancelled off. It means that each charge, the net force is 0. So the net force on capital Q is equal to 0. So we can write there are two forces, force due to the small q and force due to 2q. So we can just write k q upon x square is equal to negative minus k 2q square upon r square. You can remove both the k and one of the q's. So you will get the relationship simplified to small q upon x square is equals to minus 2q minus 2 capital Q upon r square. Let's put it as equation number 1. Okay. Now the net force on 2q would also be 0 because it is in equilibrium. The net force on 2q charge would also be 0. So there are two forces again. One due to the small q and the other one due to the capital Q. They are equal and opposite. So you can just write k times 2qq upon r minus x whole square is equal to minus k 2q square upon r square. If you again simplify by removing the common factors, you will get small q upon r minus x whole square is equals to minus capital Q upon r square. Let's put it as equation number 2. Upon r square. Let's put it as equation number 2. Now let's divide equation 1 with equation 2. Let's divide equation 1 by equation 2. So be careful, look at equation 1. So the left side should be divided and the right side values must be divided. The first divided the second one. So you will get r minus x whole square upon x square is equal to 2. You can check on that. All those terms will get cancel each other and you will get on the right side just 2. Right. So you get 2 here. Now you can solve it. You can solve it. R minus x whole square is equal to 2x square if you cross multiply. Take the square root on both sides. Now you take the square root on both sides, you will get r minus x is equal to root 2 times x. Root 2 times x. So take x to one side and then you simplify. You can get the value of x in terms of r. X is equals to r upon 1 plus root 2. R upon 1 plus root 2 x is equals to r upon 1 plus root 2. Let's put it as equation number 3. Put it as equation number 3, and now substitute equation 3 into equation 1. So instead of x in equation 1, you can write r upon 1 plus root 2. So you will get q is equal to minus 2q upon r square times x square, that is equals to minus 2q times minus 2q times r square upon 1 plus root 2 whole square times r square. So r square and r square get cancelled out. You will get q is equals to minus 2q upon 1 plus root 2 whole square minus 2q upon 1 plus root 2 whole square. That will be the q value. Thank you. We'll meet again for a short lesson soon.